Now let's look into the second group of techniques which comes under data reduction, that is aggregation. So aggregation involves combining multiple data points into a single representation. Aggregation can be done using various methods such as averaging, summing, or taking the maximum or minimum values. So let's begin with averaging. So averaging involves calculating the mean or median of a group of data points. This can be useful when the individual data points are not as important as the overall trend or pattern. So, and a single representative value can capture the essence of the data. So let me take this example here. So averaging, we'll begin with the averaging, then we will move on to the summing next. Okay, let me take the example. So this is second aggregation. In aggregation, the first one is averaging. Okay, let's load the original data set. Let's load the data set. Let's load the data set. So this time I'm gonna go with customer data. Okay, players would be fine. Players based on a team. Okay, so the data has been loaded. So now let's calculate the average of a column. Average of a column. So average is equal to, so players, and the column name, I'm going to take up this column name. So I want to go for the height in centimeter first, and mean of it. So average, it's 177 centimeters, so 177.45 centimeters. So the average height of the soccer players is 177.5 centimeters. Now let's calculate the averaging. This is called averaging. Average weight of the soccer players from the respective data set. So average weight in kg is equal to players and height, weight in kg, and go for the mean, and average kg is 72.65. That's the average weight of the players from the data set. So this is what we call it as an averaging, and we can calculate even for the average for other variables for the different data set. But you need that average to calculate the average, to calculate the mean. You need to have a continuous variable there. So next we have is summing. So what is summing? We have seen the averaging. Now we will look into the summing. Summing involves adding up the values of multiple data points. So this can be useful when the individual data points represent the quantities that can be combined or aggregated, such as sales data or financial transactions. So here is the example. So we'll take the simple example so that we can do the summing. So not we have done the averaging before, now we will do the summing. So same, let's calculate the total. Let's calculate the total height in centimeter of soccer players altogether. Everything let's keep it same, and let me change this to total centimeter. It's 2,81,615 centimeter. It's 2,81,615 centimeter. Similarly, let's calculate the total weight in kg. These are all averaging, these are all comes under data reduction only. Total weight in kg. Kg of soccer players. So total kg players, and let me change it to weight, and total kg is 1,15,301 kg. Oh, total all players together make up to the 1,15,301 kg. Okay, so that's how that's what is summing means. We have seen the averaging, that's the mean, and then we have seen the summing, that's the summation. Now let's look into the maximum. So maximum or minimum. So taking the maximum or minimum value from a group of data points can be useful when identifying extreme values or outliers in the data, or when interested in the highest or lowest value within a particular group or category. So let's find out the maximum and minimum. Of course, we are calculating the maximum and minimum in our previous example also. So maximum and minimum. Okay, let's take the same example, the players data. Now I want to see what's the maximum height. So the question is, what is the maximum height of the soccer players? So it's pretty simple. So max centimeters is equal to players, and then height in centimeter, and max height in centimeters. Okay, so now max cm is, okay, 219 centimeters is the height of the soccer players. The maximum height of the soccer player means some of the guys who has 219 centimeters of height. How many, we don't know. Next, let's look into the maximum weight of the soccer players in kg. So max weight in kg, it's 218 kg. Again, it's 218 kg. So now let's look into the minimum height. What's the least height? What's the least height? The shortest guy. Let's try to find out the shortest player. Who is the, let's, shortest guy? What's the least height? soccer players. Let me change this to min cm and min, and it's min 136 centimeters is the least, the shortest guy or maybe shortest girl in that soccer players team. So now I want to find the lean, how lean they are, the least weight. Let me go for the least weight. It's 30 kg. So 30 kg is the least weight of the soccer players. Okay. So now we have seen the averaging, summing, and then even the maximum, minimum. And now we will be looking into the few more aggregation techniques. That is counting. The next one is counting. So counting is nothing but to count. So the number of data points it holds. So counting, this is also a very important technique used in exploratory data analysis of data science. So same data, so nothing much. Players, this is the only data we'll be using now. So to count the number of occurrences of each value in a column, so I want to count the number of occurrences in country or team column. Country or team column. Okay, so I'll say team count. Team counts is equals to players, and it's country, and it's very simple, value counts. Yes, so team counts, it's total. You can see that team GB consists of 550 soccer players. Team USA consists of 52 soccer players. Russian Federation consists of 45. Australian Olympic team 42. Nigeria 1. Palau 1. Sudan 1. And China 40. So that's how, and each category inside that team counts in that column will be, the frequency of each category will be given. The frequency of each category in that column will be given. Let's take one more example. Let's take the gender. Let's take just gender here. Count the number of occurrences of male and female in gender column. So again, gender counts is equal to players. As usual, it's gender and then value counts. So gen counts. So total you have 869 men and 718 women. So still there is slight domination of men, but I hope in future that will also be stabilized. So now let's take a few more data points, and let me take to the let me bring up the customer data. So customer data, let me check customer. Okay, nothing. Customers is equal to pd dot read csv, and here it is customer segmentation. Let me check the customer segmentation. Customers. Okay, this is customer data, this is cust data, and I just want to see the customers data. Okay, let's take this customers data. So gender, age, annual income, spending score, profession, work experience, and family size. So now let's explore one by one using this counts technique. So the first question that comes to me is uh, aggregate. No, it's not. It's obviously it's an aggregation. Count the number of occurrences. Let me copy this. Let me count the number of occurrences of various family sizes. Family sizes in family size column. Okay. So everything remains same. Here it will become, okay, before that let me change this. This is customers and this is family size counts and family counts, and here it is. Oh, sorry, this family size. And okay, so out of that data, out of our customers data, so most, okay, 361 families are just of two, a number of two. That means they don't even have a kid. And 311 families has a family size of three. That means two with one kid, and then only one. This guy is a single. Maybe the girl is a single. And then 289 families has four. That means two. So five is also good. This is the normal Indian family size, five or four. And then 6, 7, 8, 9, these are Muslim families size. it's a, I'm not just stereotyping it, but that's how it works. Okay, never mind. So that's how you do that. That's next. Similarly, now work experience. So work experience, let's check now how many customers will hold different types of work experience there, different levels of work experience. So let me change this. Count the number of occurrences of work experience levels in work experience column. Work experience column. So everything remains same. Here I'll change this to work experience, and this is XP counts. And here it is. So 17 years of experience, we have only one customer with 17 years of experience. And 17 years of experience, we have only five customers. And the highest customers are with one experience or null experience. So this is where the most of the customers are coming up with. And after that, 8 years of experience are overwhelming, again 166. But one or null experience are basically an a huge and overwhelming numbers. So based on that, you have to plan your strategies, marketing strategies. So now I want to see the profession. So out of my customers, which customer belongs to which profession? This is what I want to see. Let's see. So count the number of experiences, number of occurrences of uh, various professions in profession column. So let me change this to profession, and let me say profession count. Profession count, and here it is. Okay, so most of my customers, if I see my customers segregation, breakup, so artists are 612. Okay, most of the artists are coming to my shop. Healthcare are 339. and entertainment are 234, engineers are 179, doctors are 161, executive 153, lawyers 142, marketing is 85, homemakers are 60. So homemaker and marketing are lesser. So the major chunk is coming from artist, healthcare, entertainment. So based on this, I need to customize my marketing strategies as well as the appearance and then uh, ambience of my shopping mall, so that uh, I can pull more of these professional guys to my shops, to my mall. So that's one, and we have grouping and aggregating. The next one is grouping and aggregating. Let's see what is grouping and aggregating now. So here what we'll be doing, we'll be grouping the columns. Is for that we need to use a group by. So let me take the players data again. Players, okay. So let me grouped is equal to players is the data frame, and then group by is the method I'm gonna use it. So in this, I want to group this column with this level of aggregation. So whatever, so now I want the team aggregation. I want the team aggregation with height. Okay, let me do that. So group by a column and perform aggregation. So now that's what we are going to do here. So I will group by this column, and then I will do a summation or average aggregation. Let's do that, not to worry. So now I need to give no aggregation. So now I need to provide an aggregation column. So I want height in centimeter. I want to aggregate height in centimeter with the categories of team. That's what I want. So I will give height in, sorry. Okay, it's not working here. So height in centimeter, and I want just mean. So grouped, here it is, magical. This is also called data reduction. So what I did here, I performed a group by a column and performed aggregation, example average, sum, maximum, a minimum, or another on another column. That's what I did. So here what I did is I have replaced. So I have done the group by with the categories in that group and did an aggregation with a different column based on the group by categories. That's what I did here. Okay, so now let's add a few more things. So two things to be noted down here is, one is grouping column. So grouping column normally it should be categorical. So let me write down here, grouping column is categorical. Then you will have an aggregation column. Aggregation column is equal to continuous. And then an aggregator such as sum, mean, max, min, or any of your own function that you can define and add. It is all up to you. So next thing, I want to group by a teams column based on the categories in it, and perform aggregation on weight column. Okay. So now let me check the same data. I'll go for the mean itself. So this one is fine. Teams, I just want categories based on teams. So now I'll go for the weight. Okay. No, it doesn't work. I need to copy from here. Yeah. So this I'll name it as grouped weight. Let me change this back to the code. And here is that. So, Albania has the average weight. Okay. Albania has the soccer players with the maximum weights, I guess. That's what we can tell. Okay. And you can also do the aggregation based on, let's go for the customer data, so that yeah, if you take the customer data, so here you can check sum of quantities sold by various shopping malls. That's what the question, that's what the problem statement. So find out the total quantity sold by various shopping malls. Okay, simple. Let's total shopping malls quantity is equal to, let me bring up the data frame and group by. So where is our, okay, cust is our data frame, or customers, what did we take? Cust only. So, and first let me group by. So group by is our shopping mall. Group by our shopping mall. This is done. Now I need to aggregate this one. Okay, I need to provide an aggregate column. So the aggregate column is quantity, and obviously at the end I need to go for the mean. So total shop, and here it is. Of course, sorry, not mean. Sorry. Yeah, yeah. So the following are the shopping malls. Xavier Hair AVM 14,949, Emmer Square Mall 14,501, Forum Istanbul 14,852, Canyon 59,000, huge. Oh no, Mall of Istanbul 60,114. Okay, so let's have some fun. Okay, so categories. So what quantity were sold? Okay, category and then quantity sold. That's what we'll see. The same one, but not the aggregation using. Let's see that the quantity sold by quantity sold in various categories. Okay, some remain same, quantity remains same. Here we'll put the category, that's it. And total categories, total cat. And here it is, as usual. I think clothing got 1 lakh 1 lakh 3,550. That got the highest number of products sold. So now, which has the highest sales had happened in money monetarily? What's the highest price? Now find out the total quantity. Find out the total selling price in various categories. Okay, let's take this one and put it here. Category, and here I'll go with the price. Let me change this back to the total price. Total price. Okay, again the clothing because of highest. No, after that shoes and technology. This is okay, 3-1. This is 1-5. Then 1-8. So clothing first, then shoes first, then technology. So now let's go based on the shopping mall. Okay, price. Let me copy this from shopping mall. Total price and shop. Okay, again Mall of Istanbul, and then after that Canyon, then Metro City. Mall of Istanbul, Canyon, and Metro City. This is how we leverage the grouping and aggregating. So now the last one we'll see, the last one but not the least one. It's a custom aggregations. So let's see what is custom aggregation. So here we have done the aggregation there. Or there we have used the functions which are existed, the methods which are existed in our previous case. We have used the functions which are existed like sum, mean, min, and max. But here in custom aggregations, we will be defining our own functions based on our requirement. That's what is called custom aggregations. So it's pretty simple. Everything remains same other than having our custom defined functions. Custom defined functions. So let's take one example. Everything remains same. So let's also import numpy here, and we'll take the same data, players, and now let's define one function. Let's define a custom aggregation function. Let's define a custom aggregation function. So def custom ag, I put it x inside that. Then what do you want to return? Custom aggregation logic. So what I want to return is np dot sum of x and divided by np dot count non-zero of x. So that's what is our custom defined function. Okay, so now let's apply custom aggregation function on a column. So custom aggregated value is equal to players. Let me take the players. Column name as usual, team. Sorry, country or team. And here I'm gonna go for the ag, and yes, inside that aggregation I'll put the custom ag. That's what the function name. So, and okay, so unsupported type for, oh sorry, let me change this to the height in centimeter. So now custom aggregated values, and here is that values. So 0 1, this is how the custom aggregated values. You can apply your custom aggregation function in spite of using your using the default aggregation functions. That's what is custom aggregations. So this is what we call it as aggregations, and this is how using the aggregation techniques we can reduce the data. You can achieve the data reduction.